All right, so today we're going to look at kind of the last thing with naming and writing formulas here right before break on Tuesday, and that is doing ionic or covalent compounds. Now, the idea is that when we first talked about naming, there are two types of compounds, ionic and covalent ones. And last week we spent with naming the ionic compounds and writing their formulas. Well, today we're going to look at the covalent compounds. And just like the other ones, we'll talk about how the bonds are made later. Now we just want to name them and be able to write their formulas. And luckily, these are easier than ionic compounds. There's not different levels. We can do all of them at the same with the same set of rules. And there won't be a separate polyatomic ion sheet. We just need to have our periodic table. Okay, and there's a lot of different other parts that make them a lot easier to do. So this should be pretty straightforward. All right. So again, the two things that we'll always need for covalent compounds is we'll need our periodic table, and we'll also need a prefixes chart that you'll be always be given for a quiz or anything that looks like this, because we're going to talk about how these prefixes are going to be really important. All right, so we're going to talk about naming covalent compounds, and then we'll do some examples. We'll do some examples here, and actually, I'm going to grab one example so that we can use it when we're learning the naming rules. And then naturally, it's going to follow from how we learn how to name them. We can work backwards, so we can write the formulas, and it will be pretty straightforward with that too, so we can do it in the same time. So let us begin. Right. So one of the example we're going to do is this compound, and that so we're going to talk about the rules. No, I don't want that. All right. So the first thing is all covalent compounds are made with two non-metals. So if we go up to our periodic table, remember how ionic compounds had one metal and one nonmetal? So these things over here are nonmetals in the green, and metals are pretty much everything else. Covalent compounds only occur between two nonmetals. So we're looking at these small sliver of elements right here are the only ones that we're going to talk about. So when two of those are able to combine, we get a covalent compound. So um, when we review next week about all naming and you have to pick whether something is an ionic or a covalent compound, that's going to be the first step is figuring out if there's two nonmetals or a metal and a nonmetal atom. Okay? So all covalent compounds are made with two nonmetals. Number two, our naming um, strategies will not be for compounds that contain carbon. So we're not going to talk about how to name organic compounds because meaning containing carbon, because that is a completely separate set of rules. And since this year we're largely not going to deal with a lot of organic compounds in our reactions, maybe besides like alcohols, it's not something that's super important for us to have to talk about. So while carbon is a nonmetal, um, we're not really going to deal with it as far as how we're going to name things. So organic naming is it's a separate thing. Okay. 3. We are going to look up the first element in the compound on the periodic table and find its name. So, in this case, our first compound, Si, I'm looking it up, and it's going to make it a lot easier to find because I know it's going to be over here. And Si is silicon. All right. Then we are going to find the prefix on the prefix chart that goes along with the number of silicon atoms we have. So look in our formula. There's 2 silicon atoms. So we're going to look up 2 in our prefix chart. And 2 is di. So if I copy this over again, put it down here, says we have 2 silicon atoms, so 2 is di in the prefix chart. Write the name of the first element in our compound with the prefix in front of it. So I'm going to write disilicon. Okay? That's that's what I'm going to start by writing. Okay? Look up the name of the second element in our compound. So if we go to our formula, Br is bromine. All right? And then I'm going to redo step 4. Find the prefix on the prefix chart that goes with the number of bromine atoms we have. So we have 6 bromine atoms. On our chart, that is hexa. Okay? That is hexa. So if we have, let me copy this back. Br6. If we have 6 bromine atoms, the prefix for 6 is hexa. And then we're repeating step 5. Write the name of the second this time in our compound with the prefix from it. So now we have hexabromide. All right, with the prefix in front of it, and then all right. Don't forget to change the ending to "ide." Then lastly, this is 6, 7, 8, combine the name for the first and second atoms together. So this compound in total, we would take disilicone and then hexabromide and put it together. So we say that this compound is called disilicon hexabromide. And this is our name. Right? So what did we do? We looked up each of the elements' names on the periodic table, and then we looked up the word for the prefix that goes with each of the numbers, and then we put them together. So disilicon hexabromide. So here's some other examples. Okay, we did this one, right? This was disilicon hexabromide. All right. Like for number 13, when there's no number next to it, we only have one. We don't need to use mono. We can leave mono off. So this one would be sulfur tetrachloride. We don't say that this is monosulfur tetrachloride. It's just sulfur tetrachloride. Or in this case, nitrogen trifluoride. It's not mononitrogen trifluoride, right? Okay. And the last thing that I wanted to share is that sometimes compounds, so the way that we're learning how to name ionic and covalent compounds is the proper. It's called, um, the formal nomenclature, the systematic naming. Okay. Um, all compounds have a systematic name, just like all animals have a Latin name. There'll be a lot of substances that go by other names more commonly because they have just been used so much that that's what everybody knows. For example, this compound is technically called dihydrogen monoxide, but everybody just calls it water. Okay? Or this compound, nitrogen monoxide, nitrogen monoxide, most times is just called nitrous oxide. All right? I don't really, you need to know the systematic name. If you know the common name, that's great, but I'm never going to test you on the common name. So you'll never have to know that this is called, you know, nitrous oxide or anything like that. Going backward from the name to the formula, you just do the steps in reverse. So if it's hexaboron, hexa is six borons, and then looking at the second one doing the same things like dioxide, two oxygens, iodide, iodine, pentafluoride, five fluorines. Okay, so these rules are a lot more straightforward than the one from the ionic compounds because there's no levels. They're all using these, and it's pretty clear what to do because there's only a small group of elements that you can choose from. And the chart right here tells you what all the prefixes should be. So that should really be